I must preface that any information in this video is to be educational only and is not to be interpreted as financial advice. You may have heard of the 24/10 rule when buying a car. It's fairly popular advice in the personal budgeting community, but if you're like me and enjoy seeing how the numbers actually play out, then you may find yourself less than satisfied with hearing 10% of your income and calling it a day. So what I'm going to do is run the numbers and provide some formulas that you can use using some examples so that you can apply this rule with a little bit more intention and precision. Before we begin, I'm going to explain what it actually is. So essentially 20 just refers to the percentage of the car purchase price will be what your down payment is going to be. 4 refers to the 4-year loan term, and 10 refers to 10% of your gross monthly income should be what your maximum monthly repayments are going to be. Let's dive straight into the math because that's what we're all about today. There's already plenty of videos out there explaining where 24/10 may or may not be appropriate, but today we are simply interested in the math in accordance with 24/10. So let's say that your gross annual salary is $70,000. This will be one of the two variables, being your income and the interest rate of the loan that you're applying for. So at $70,000, your monthly gross income will be $5,833. And so 10% of your monthly gross income will be $583, which will be the maximum monthly repayments as recommended under the 24/10 framework. Okay, now we know what the maximum monthly repayment should be. Great, but it still doesn't give us any further insight into our borrowing power so that we can determine what the principal amount of the loan should be, as well as the maximum car purchase price and 20% down payment. So let's first identify what the principal amount of the loan should be in accordance with 24/10 using the same above example. Just to recap, the principal simply refers to the loan amount that we are actually going to apply for before it incurs any interest, otherwise known as the present value. And the way that we're going to determine the principal is by using the above equation, where P denotes the principal that we're trying to determine. And I'll go ahead and pop up a table so that we can break down what these other variables mean. The following table lists the variables and their corresponding meaning. P, we already know, represents the principal, which we are trying to determine. Capital R refers to the monthly recurring payments as a dollar amount, so we can assign a value to this given our working example. The lowercase r refers to the interest rate of the loan expressed as a decimal, and for most of the internal calculations in this tutorial, I will be using up to 5 decimal places. The N refers to the number of payment periods. Now, given there are 48 months in a 4-year term, N in this case will represent those 48 months. And then finally, this formula, which is known as a present value interest factor of an annuity. Basically, it's a dimensionless multiplier used to multiply a regular payment to calculate the present value of a stream of equal future payments. Let's return to our working example. So based on a monthly repayment of $583, represented by the capital R, let's introduce the second variable being the interest rate. So let's say that the interest rate of the loan is 7% per annum. So 7% per annum divided by 12 months will give 0.00583, represented by the small r. And then, of course, N will be 48, given there are 48 months in a 4-year term. Let's calculate the loan principal, or solve for P. So let's take our equation and replace all of the variables with our known values. Pretty self-explanatory, that's step 1. Step 2, add 1 to the monthly rate. This will give 1.00583. And as I said previously, we're going to be working with 5 decimal places for most of the internal calculations. Step 3, raise it to the power of negative exponent n. In this case, negative 48. Now, why the negative exponent? Well, when we're paying off a loan, each future payment is technically worth less in today's dollars. So what the negative exponent does is shrink future payments down to today's present value. Step 4, subtract the previous result from 1. This will give 0.24348, still retaining the 5 decimal places. Step 5, divide that result by the interest rate, being 0.00583. This will give 41.76329. Step 6, multiply that result by the monthly recurring payment, being $583. This will give $24,348. This is our working principal. So now we've worked out the principal, and if we didn't have a down payment saved, we could still buy a car at this price point because the whole cost would be financed. But under the 24/10 rule, we would ideally put down 20% upfront. So to figure out the maximum purchase price, we'll scale this up to represent just 80% of the car's value, and that will tell us the total price we can afford under the 24/10 rule. To find the total purchase price, which we'll call C, we divide the principal by 0.8 since the loan represents 80% of the total cost. I've left the blank formula below for reference. Now we just substitute in our known values, which in our case is 24,348 divided by 0.8 equals 30,435. This means the maximum car purchase price, while sticking to the 24/10 rule, is $30,435. Now that we've calculated the maximum car price, we can figure out the down payment. We'll call this D. Under the 24/10 rule, our down payment should be 20% of the total car price. So the formula looks like this: D equals C times 0.2. Plug in our values. D equals 30,435 times 0.2 equals 6,087. So we'll need to contribute $6,087 upfront as our down payment, and the rest will be covered under the loan. And that's the 24/10 rule explained using real numbers and real math. If you found this video helpful, please like and subscribe, and comment down below what you would like me to cover next. Thanks for watching the video, and I'll see you in the next one.